So just let me know if you cannot hear me at any point. The passage is primarily concerned with...
Please switch off your audio, everyone. Please mute it.
Janavi, I'm muting everyone. You just unmute yourself.
All right.
Okay, you can start, Janavi.
All right. Good evening to our honorable principal, Dr. Sanjay Bokade, head of the Department of Instrumentation, Dr. S.P. Sadala, ISA-RGIT faculty advisor, Professor Dipali Joshi Jain, and all the teaching and non-teaching staff, students, and participants present here on this virtual dais. I, Jannavi Sail, President of ISA-RGIT Student Section, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Instrumentation, welcome you all to this Alumni Speak series. The purpose of the series is to guide the current students to make a qualitative analysis of their respective field, interact with our experts, and carve their own path to a successful career. Before introducing today's speaker, I would request our Honorable Principal, Dr. Sanjay Bokade, to say a few words on this occasion. Over to you, sir.
Thank you very much, and I'm really very happy that our alumni has joined us to speak on some very good topic. Yeah, thank you. Am I audible properly to all of you?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, and this is.
All right, sir. Thank you so much.
Yeah.
Today, in this Alumni Speak series, I take this opportunity to present before you.
Janvi.
Yes, sir.
Yeah.
There was some interruption, I think, because I started speaking, but there seems to be a lot of time lag today.
Yeah.
Right. Okay. Let me just one more time put my my small views.
Yes, sir. Definitely,
function. Sir. So, in fact, I'm very happy to see our alumni joining us and speaking with all the students. And this is regarding the career building, right? If I'm not wrong, the topic of today's talk is career building. Career guidance, career building.
Yes, sir. Yes, sir. Career opportunities.
Career opportunities and everything. So that is really something which must be thought about at this point of time when students are getting graduated. They are in their third years or in the final years. And more briefing would be given by our alumni, JUNIYALI, and you all will listen to it, no doubt. But few things which I would like to tell to the students watching us. I welcome all of them, those who joined in the Zoom room as well as they are live on the YouTube. Your career and setting your goals for your life makes a lot of meaning there. Because if you do not set your goals and then you are sailing like in a boat which does not have, which is not been controlled in any way by directions. So there should be certain goals, and you must have some career planned at your mind, and you can walk upon it. Now there are a few things on today which we have to see that you need to understand first of all what does this career mean. Does this career mean that becoming an engineer working in some company, or you become a doctor and that's it and that is your career? No, career has got a lot of other dimensions also, and you need to know about those dimensions. Then it is your responsibility towards your family, towards your profession, towards your society, and that makes the comprehensive definition of your career. You're working in some field, but you're working in some field must give an opportunity to you to serve other so many fields. And a student of today or everybody on today must know about one very important thing, which I many times repeat in whenever I get an opportunity to speak somewhere, which is a famous quotation, which is a very influential quotation, which I have actually been influenced by. The quotation is given by Mr. Alvin Toffler, and what does he say is that illiterate of 21st century will not be the one who does not know how to read or how to write, which is primarily the definition of illiterate, that he does not know how to read and how to write. But Alvin Toffler says that from 21st century, the one who does not know how to read or how to write will not be the illiterate, but illiterate of 21st century will be the one who does not know how to learn, then unlearn, and then relearn. And this is what is very meaningful. It's $1 billion advice to everyone, that we should always be open to learn. Then over the period of time, there are things that gets obsolete, that takes a different shape, and you have to unlearn something that was learned earlier, and you need to relearn something. At a point of time, if you say that, no, I don't want to now learn this online meetings and Zoom meetings, and I should not try to know what a Google Suite is or a Zoom is, how to host a meeting. If you put a full stop on your learning there, then you may be thrown out of the competition. So to remain at least literate in 21st century, all of you need to know that you should learn, you should unlearn, and you should relearn the new and the most upcoming technology. So with this, I close my 2 words. I have spoken more than 2, but then thank you so much. And then now it can be over to the host. Yeah, thank you. Thank you so much.
Thank you so much, sir, for your valuable advice. We'll definitely explore the dimensions you spoke about. Today, in this Alumni Speak series, I take this opportunity to present before you our first speaker, Ms. JUNIYALI NAURIYAL. JUNIYALI NAURIYAL completed her BE in Instrumentation Engineering from Rajiv Gandhi Institute of Technology in 2016. She was awarded the Best ISA Student Award 2016 by the ISA Maharashtra section. She has completed her MS degree from the Institute of Optics at University of Rochester in 2018. She has also been awarded the Harvey M. Polyakov Memorial Scholarship in the 2018 by the OSA. She is a PhD student of Electrical Engineering Department at the University of Rochester, working on designing, fabricating, and packaging integrated photonic devices. Her achievements also include 3 publications in the technical conferences. Ms. JUNIYALI NAURIYAL has published her first paper on fiber-to-chip fusion splicing for robust, low-loss optical coupling in Clio OSA in 2018, second research paper on low-loss and robust photonic packaging using fusion splicing in Clio OSA 2019, and third research paper on fiber-to-chip fusion splicing for low-loss photonic packaging in Optica 6.5 in 2019. But that's not all. In addition to these, Ms. JUNIYALI NAURIYAL has 1 patent on system and method for attaching optical fibers to chips in her credit. Now, after knowing about all of her amazing achievements, it's time for us to hear from the speaker herself. JUNIYALI ma'am, over to you.
Thank you. Thanks a lot, everyone, for inviting me and giving such a nice introduction, Janvi. Thank you, Principal Sir. Thank you, Sadala Sir, and all the staff for giving me the opportunity to talk about my career and how I, started from bachelor's and I'm a PhD student here. So first of all, today I'd like to start about, I'll start presenting and then I'll go over how, I'll just do the slideshow. So the topic for today would be navigating through graduate school. And as Janvi said, my name is JUNIYALI and I'm doing my PhD currently at the University of Rochester, which is in New York. I'm a 3rd year PhD student and I'm doing complete research right now. So I just wanted to talk about the things which I think would have been amazing to know when I was a student at RGIT or just a bachelor's student, because we are not aware of a lot of things which might help in our career later on. So my talk would be divided into two parts. The first would be how I started from RGIT and went to PhD. And after that, we can have a little bit of question answer session, so that if you have some urgent questions there, you can just ask about it. And then I'll speak a little bit about my research. I trust you, I would not be boring you guys. So it'll be hardly 1 or 2 slides about what exactly I'm working on in my PhD. So let's start with my background. And as you all know, I am an alumni from RGIT Instrumentation Department. So I joined RGIT in 2012 as an institute for instrumentation engineering. The biggest reason why I joined instrumentation was that when I just passed my 12th standard, I sort of liked everything that I was studying. I knew I did not want to do computer science, but I liked mechanical engineering. I liked electronics. I liked EXTC. And then I saw instrumentation engineering. And it sort of was the perfect blend of all mechanical, automation, electronics. And I was like, yes, I want to do this. I really like studying this. So then I started with my engineering in instrumentation. So after that, I went ahead and I knew I wanted to do higher studies. So I went to University of Rochester. I applied to, I think, 4 colleges and I got admits from all of them. But I applied for a master's program, and at the University of Rochester, I got admitted into master's in optics. And when I was going through the university, what they do, I figured that it was top ranked. It was #1 in US for optics. So I was like, okay, sure, I'm definitely studying optics now, because the only optics I knew before I joined University of Rochester was Anuja ma'am's class in analytical instrumentation, where she was teaching us MRIs and sources and detectors and IR sensors, all these things. So I was like, yeah, this is pretty cool and I want to do this. So I started in my master's as in optics. And I graduated in 2018. And after that, I liked what I was doing so much that I was like, okay, I should probably continue into a PhD. And then I did it in electrical engineering. So the reason I'm starting my talk with telling you about the various fields, the various degrees I have, is to show you the transition I had from instrumentation engineering to optics and now in electrical engineering. So this sort of tells all of you guys that it is okay to change streams and to do something that you like. And as Principal Sir just said, you should be ready to learn and unlearn. So I knew enough optics to get into the master's degree. I had to study a lot, definitely. And then I thought electrical engineering aligned better with the research I was doing. So I went ahead and converted to electrical engineering. So this is something I initially thought was an issue and would have liked somebody to clear it for me. So I would jump right into what opportunities we generally have after the bachelor's. So I made like a flow chart to explain things. And the first thing is, when you're in your 4th year, you get your degree. So you're an instrumentation engineer now. So you have 2 options. You can either go for higher education or you can get a job. And it's amazing to get a job directly after instrumentation if that is what you want. But if you want to go ahead and study further, want to get a master's or a PhD, you have 2 more options. You can either study abroad, like in the United States, Germany, a lot of other European nations, Australia, New Zealand. I know a lot of friends who have done that, and that has worked out pretty well. So if that is something you want to do, you should look into those options as well, even Canada. So, and then the other option is to do it in India itself, which is not at all bad. But if you want to do it, you should follow what you really want to do it. I have highlighted the path which I took. So in my instrumentation engineering, I knew I wanted to do research because I loved it. And so I knew I wanted higher education. And I sort of knew I wanted to do it abroad, but I was not sure which country to do it, which field I'm going to do my higher education in. And that's how, while I was deciding through my second and third years, I figured, okay, initially it was more towards Germany because of their automation and amazing skills there. But then I sort of shifted to US. So then it was, I knew I wanted to do higher studies, and then I wanted to go to US to study and do some more research. So with that, I would like to talk a little bit about my bachelor's in instrumentation engineering. And I want to start off with a meme because this generation is all about memes. So here it is what, when I used to tell anyone I'm doing instrumentation engineering, people thought mostly this, that I'm working with some engineering regarding guitars or pianos or any instrument. But what we were really doing was we were testing flow control valves in Professor Shende's labs, and we were doing control system designs. There was power electronics. There was so much more that we were actually studying. There was automation, and it was very nice. So from my side, what I think the biggest skill set that I learned in my engineering was that it taught me how to think and how to solve any problem. So it was not just about process control or automation. It was how to approach a problem in a very, very engineering specific way. And I think that is what makes a difference between a regular person and an engineer. And this is a skill set which is very, very important in the current world. So then I went ahead and did my higher education search and graduate school. So I'll go over the important things which is needed for higher education if you want to apply and how you can do it. So I think everybody would be interested in this slide. And because when I was a student, and I'm still a student, but when I was in my bachelor's, the biggest question was everybody was talking about GRE. You know, you have to give GRE, you need a 330 plus, you need 320, you need to get full score. But I think it's important, but getting a reasonable score in GRE works out. You do not have, GRE should not be your main concern. Because as a student, we study for GRE for maybe 1 or 2 months, and that's it. But what I saw through my application process and through my admission process, because I was not expecting myself to get a admit from one of the top universities in US, and I did get. And the biggest reason was my GPA. I had a GRE of 310, which is very average. So anybody who's worried that GRE is not great, don't worry, that happens. And I think everybody knows that. So in GPA, it's very important. A lot of the universities just care about your GPA. If you have an 8.0 plus GPA, you're golden. You can get into a good university. And another thing which I really want to point out to everyone, because I wish somebody had told me initially, is that, you know, when we're talking and we're saying that we'll study in our 4th year because that's our BE, that's our final year, we'll study then, we'll get a good grade then. That does not matter if you're going for any higher education or even applying for a job, because all the job applications on the campus placement starts from 3rd year. So you need to have a very, very nice GPA till your 3rd year. So guys, start concentrating on your GPA 1st year, 2nd year, and 3rd year. If you don't want to study in your 4th year, it's up to you, but please study till your 3rd year. And then the last part is your statement of purpose, which a lot of students have problem with. And that is where students don't get in. The problem is that, you know, in India, we have the trend of going for GRE counseling classes where they give They write your statement of purpose for you. But everybody who's reviewing your applications in US or in any other country, they know that a third year bachelor student is writing it. It's very evident to figure out if it's you writing or somebody else writing, because they have templates set up, and that sort of gives you negative points. So my advice would be to keep a consistent GPA and just don't keep studying. I did not do that. I was not always studying. I did everything else as well. So you need a balance. I'm not telling you to get a 10-pointer. Just get 8+. That'll be a good enough score. And then you can do some extracurriculars to balance out. And that is what I'll be talking about next. That how you can improve your CV or your personality to get into a better university or even get a job, because this applies everywhere. From my side, I would say you need to be involved. And the biggest way you can get involved is, this is an image from our ISA orientation in our last year, where this was our entire committee and we organized a lot of events. It was really nice and it was a great learning opportunity. So I would suggest everybody join some organizations. There is ISA for instrumentation engineers, and we really have a very strong IEEE society as well. And every department has their own societies. So join those societies and take part, and don't just take part in these competitions. If you really want to make a difference, you need to initiate things. You need to start by giving them ideas, working on it, and making a difference. And that really adds to your skill set. So in our time, there's one thing, we started a new contest, that is the mini project competition. And it was amazing. It was a success because all the students got an opportunity to put in their engineering skills and come up with a product which they can actually physically see, feel, and relate to. So that was super cool. And if you don't want to be involved in, you're not so comfortable in taking charge and organizing events, that's completely okay. There are so many technical fests and competitions that happen, I would say, every other week in Mumbai in some or the other colleges. So you have an array of these fests happening, so many competitions happening, and take part on those competitions. It's okay if you don't win, but it helps you develop skills which you need for future. For example, Bharatiya Vidyapeeth had a lot of quiz competitions, and we frequently went to those quiz competitions. We also came first once, and then the other time we did not, but it was fine. It helps in making connections, seeing what others are doing, and is really helpful. So my suggestion is take part in technical fest, volunteer for cultural events. If you're not so technical, that is completely fine. Or just initiate some more, just get involved. How much ever involved you can get, that would help you. And the other thing is, that was the CV part, how you are adding, how you're, there was like the extracurricular that you want in your resume or your CV. The other thing is, how would you add value to your statement of purpose? Because I already wrote in my CV that, I was the technical secretary for ISA. If I'm reading somebody's statement of purpose, they would not understand what I'm talking about. They'll be like, yeah, I just read it in her CV. What's the difference? So you need to write in your statement of purpose what skills you learned being a technical secretary or being a president somewhere, or just volunteering somewhere. So for example, if you volunteer in a cultural event, you would talk about skills like you learned how to collaborate with others, how to work in cooperation with others, how this helped you grow as a person. It helped you develop new skills which are needed in any job, it doesn't matter if you get an instrumentation job or a mechanical engineering job, you need these skills in any workplace. So these are the things they're looking for in your statement of purpose. So try to use all your pointers from your CV or resume and add them in your SOP in a way showing you have learned something like leadership skills. You learned how to talk to a person. You learned how to put your point across. And these are the things everybody wants. These are the soft skills everybody wants. So this is mostly what is the gist or the most important things if you want to go for higher education or even apply for a job. And the other thing, which I think it would have been great if I knew before I started applying, was the entire difference between doing a master's abroad or just doing a PhD abroad. So here is a slide showing the difference between master's and PhD. I think there's not awareness about how exactly PhD work. I'm pretty sure amongst everybody who's listening or watching, there's just one or two of you guys who actually want to do PhD, and that's completely okay. But I just want to make sure those one or two students know they have the option to do this. So a master's is for 2 years. And if you're doing it abroad, you have to pay for it in dollars. So it's super expensive. You also have to pay for your living. So that adds up to a lot of money. So you need to take a loan. Master's is generally very course specific. So it'll be mostly like your bachelor's again, but you'll be in another country and taking courses and just for 2 years. So if you want that, that is great. It'll just add to your resume or your degree qualification, but there's not really any research. I wanted to do research in my master's, so I had to take these thesis credits to work on my research. Otherwise, there was not much scope. And you can start applying from 3rd year. As I said earlier, that all these applications typically start in 3rd year. And you can have an average GPA amount like 8.5, 8.6 to get a good master's university. The other thing is in PhD, it's a long commitment. It's around 5 years. But the biggest benefit here is you do not pay for your courses. It's free. And you also get a good stipend. The stipend is good enough that you would save some money every month for your future. So it's not just a really less amount of money, it's good enough money. And you get to do research with coursework. So it's very flexible. I suppose I'm right now just taking one course and doing completely full-time research. You can have patents, you can start a company. I'm going to do that very soon. So there are a lot of things you can do while being a PhD student. And, when we talk about PhD, I imagine Einstein or somebody looking like him with white hair and really old because he's doing a PhD in physics. You cannot really do that. But trust me, guys, it's not that bad. And the biggest thing is you can apply for a PhD directly in your 3rd year. You do not need a master's degree to apply for a PhD degree, at least in US. So if you want to just go ahead and do it, you can apply in your 3rd year. You do need a really good GPA or some amazing extracurriculars. So I would say you would need like a 9+ GPA, or in the US and the international scale, you would need a 4.0 GPA to be in that criteria. To get a good university. You can definitely get a lower ranked university at lower GPAs. But if you want to go abroad, you should aim for a good university. And I mean, if I knew all these stats and how GPA only mattered, not me, but you guys, you can aim for bigger colleges like Stanford, Harvard, MIT. We think it's really hard to get there, but it's not. It's pretty simple. You just need to know what they want. And you just need to have a good statement of purpose, a good GPA, because that's all they can see, right? We do not have any work experience. So what makes a difference is if you have a good GPA or if you don't. So those are the things about master's and PhD. And with that, I would like to summarize the first part of my talk, how I went from instrumentation engineering and ended up in PhD in electrical engineering. So to summarize, the biggest thing or the takeaways I want you guys to take from this section would be that GPA really matters, and so does extracurricular. So you need to find a perfect balance between these two. And it's okay if you do not have a great GPA, but if you are doing amazing extracurricular activities, people see that and they would be okay hiring you or giving you an admit. So with that, I would like to take a break here and open the floor for some questions if you have any till now, and then we can go ahead and talk about mostly my research. So it'll be a nice time if you have questions right now, and then we'll definitely be taking more questions later on. So the floor is open.
All right, ma'am. Thank you so much for providing us a great in-depth overview of your entire engineering journey. It felt so real that we could relate to it like anything. We really liked how you touched upon some extremely important topics like personality development, participation, volunteering, and very importantly about the significance of balancing your studies along with the extracurriculars so subtly, and answered some of our doubts in your talk itself. Now we'll go on for a quick Q&A session where JUNIYALI ma'am will address our doubts. So if anyone has their questions, they can just ask her.
Hello, ma'am. It's Unnati. I want to ask you about the job opportunities. Like after the COVID-19 pandemic, what will the job opportunities be like?
That's a very interesting question. And so after the pandemic, I would say the jobs that were affected the most are the jobs which are very flexible. So the low tier jobs. But if you have so many skill sets that, nobody else has those skills, they are going to hire you no matter what. So it has affected, I would not say no, but if you have a master's degree or if you have a bachelor's and you are really strong in your field, you know your things, getting a job should never be a problem for you. And, if you can balance out things, you'll definitely get a job.
Okay. Thank you, ma'am.
No problem.
Hello, ma'am. It's Yash Mistry here. I would like to ask you, what was the major difference you experienced in the education system of USA? The comparison of that in India.
So frankly, there was not really any difference between the education system in US or in India. I think the teachers are same. So I liked how everybody in RGIT taught us, and it was very similar the way they were teaching us in US. Yes, we definitely had, the biggest change was we used to get weekly assignments. So there were weekly homeworks. It was like going back to school. We were given home, if I'm taking 3 courses, I had homeworks due Monday, Tuesday, Wednesday, and I have to submit them because they made up my grade. So I was not used to it. And when I just went there, I was like, yeah, these are just assignments. Like, how we take assignments at RGIT, we just finish it at the last day. So I thought I'll just finish it at the last day. But that did not work out well. My first assignments were horrible because, I did not put in effort. And here you have to put in continuous effort throughout your studies. So every week I'm solving questions, and the finals are not that important. So every week I'm solving problems, giving some marks, and they have like 40-50% of your grade. So if I don't study in my finals, I'm fine.
Thank you, ma'am.
The next question is, ma'am, do we prefer universities which offers hybrid courses or offline courses, especially in the post-pandemic world?
So currently, because of all the immigration rules are changing and things are varying, I would say you should look for hybrid universities which are offering online as well as offline, because that's just a safe bet right now. So if you want to do that, you should definitely go for hybrid. But if your top university or the university you really want to go only offers online, it's okay. You should do what you really want to do. So I don't think so the rule is going to come out, or I mean, they have taken down the rule, so it's not a problem. But even if it happens again, I don't think so it's going to work out. So yeah, if there's, suppose you want to go to Harvard and they only offer online, it's fine, just apply there because it's Harvard. But if there's another option, then choose the university which is hybrid as compared to completely online.
Okay, thank you, ma'am.
No problem.
And one of the questions which our SE and TE students have is how to find that balance between academics and extracurriculars, as you mentioned in your presentation. So if you could say anything about it.
Okay, so I think I'll be telling my secret here because so I would never study when I went back home. I only studied before the exams. But the secret was whenever I was in a lecture or in a class, I would be studying then and there. So it was 8 hours every day studying when the teacher was teaching, and that's it. And then just revise it before the exams. And so that gave me a lot of time. I'm only studying when, suppose Shende sir is teaching, and he keeps on asking questions. So it's very interesting that you have to pay attention. So if you pay that much attention in all the classes, in every professor's class, you would definitely not have a problem with time management. And then you can just be like yourself, president of ISA, and still get a good GPA and organize multiple events and do so many other things. If you're not into studies, you can, after 4 o'clock, when you're done with college, you can go and play outside. So there's so many things if you utilize the time you're in college properly.
Thank you so much, ma'am. I hope the TE and SE students are listening and they'll use this advice wisely, all the time management.
No problem.
Hello, ma'am.
Yes.
Gaurav here. Ma'am, I wanted to ask you, like, there is always a cliche thing which we follow, like, if we need to grow in terms of salary and also in terms of technical knowledge, we always have to shift companies.
Right.
So is that still going to work after pandemic?
So, so I have not been in the job market because I did not work. So I'm not So I'm not sure about that answer, but I'll give you my advice as I have friends and who have been doing the same things. So a lot of the times when you join a new company and you see that you're not progressing, I think it's very specific to the job you are at or the company. If you see that you're growing in the first 2 years, I think you should stay there. But if you see that you have made no progress in the first 2 years, then it would be a better option to move on, change something, or figure out what's happening. Why are you not growing as you're supposed to? So you need to figure out if this is where you wanted to be in 2 years of your work life, or is this something, there's something definitely going wrong. So you need to figure that out and then work through it. And you can definitely change companies. In the pandemic, I would sound like parents, but I think it would not be suggested to change a company if the situations are so bad right now.
Even if the progress is not that good?
So I think you can, if you are in a company for 2 years and you think the progress is not good, I think you can wait 6-7 more months.
Okay.
Wait for the pandemic to get over. And when things, I mean, it's not going to get over very soon. So when things calm down a little bit, then you can start changing. But you should always keep looking for new opportunities and better opportunities.
Thank you, ma'am.
No problem.
Ma'am, I think we should start with the next session now.
Yes. So now it'll be a little technical. I hope you guys don't fall asleep. So now it's what my journey at the University of Rochester, where I did my master's and then my PhD. So my PhD is in integrated photonics, and the image here you can see is I'm working in a lab, and you can see I'm smiling. I'm super happy working, or I'm just posing. So here I'm working in my lab and I'm happy. So do something that makes you happy. That is what I wanted to show from this picture. Now let's talk about what exactly is optics and photonics. I think I've always taken weird paths in my life. So whenever I used to say instrumentation, people thought, okay, she's working with instruments. And whenever I say I'm working in optics, people think I'm probably making glasses for others. But here I'm trying to tell you what exactly is optics and photonics. So yes, optics is lasers, playing with lasers day and night. I don't play with these green colored lasers or the red color. I do play with the red colored ones, but not the green ones. And the lasers I use can actually burn holes in walls and through me actually. So when I'm working with the laser, I need to wear a fire retardant lab coat so that I don't catch fire. It's cool and it's dangerous. So I think I like that balance. And then optics is also optical fibers. So optical fibers are just, total internal reflection in action. That is what I called optical fibers. All the communication in the world happens in them, through them. So these are like the new thing. And then I call it the word of the century. Every superhero sci-fi movie uses nanophotonics or nanotechnology. And my research is very much related to nanophotonics and nanotechnology. So yes, I work in cool things and it is super cool. So I really like it. And optics is a mix of lasers, fibers, light, you see, and so many more things. So now I'll be talking a little bit more about what is nanophotonics or nanotechnology. Everybody here is an engineer or on the way to become an engineer. So we are very familiar with electrical circuits. We go to labs and are working, wiring these things, soldering them, trying to make how these works. But so electrical circuits use electricity, very obvious. And what we're trying to make now, it's the future, something that I would call, we're trying to shift from electrical circuits to photonic circuits or nanophotonics. And here, instead of electricity, you use light. And light is not this light which we see everywhere, it is the laser, how communication actually happens. So instead of electricity flowing in those ICs, now you have light flowing in them and you're making every possible thing with it. So why am I actually working in this technology if it's so much future ahead and we don't know what it is? The biggest difference between electronics and photonics is that if you have taken power electronics, you know that transmission through electrical wires generates a lot of heat and power losses. And that's where optical fibers or light comes in. All the communications are done using light. So whenever you get a new internet connection, everybody asks you, is this fiber cable or is this the regular one? So the fiber cable is actually optical fiber because it's traveling at the speed of light. So that is where we're using nanophotonics. So few of the applications is another amazing word of the century, quantum computers. You can make these cool computers, which nobody knows how are going to work, but using light. The other thing is telecommunication. Telecommunication, if we have anybody from EXTC listening, they can understand that everything that's happening around the world, all the communication that happens, long haul communication throughout the countries, how I'm on Zoom right now, happens through optical fibers. And it also uses photonics. The other thing is data communication. These big data centers, how you're using Facebook every day, your Instagram, your Snapchat, all of these big companies have big data centers and they use data communication. They communicate data using light or photonics again. And that further helps. This is because the reason they're using is because it's faster and because it does not generate a lot of heat. So this is, I would like to sort of finish it here, but I want to show you what my end product is or what my PhD research looks like. So this tiny little rectangular box that you see is actually a nanophotonic device. The size of this device is 2 millimeters cross 3 millimeters. And this could be the size of an entire computer. So our computer right now, the laptop I'm using is pretty thick. But if all the processing can go into this really small chip, that can be the motherboard. And you can minimize everything so much. So this is an optical fiber which I'm holding. And you see, so the light travels in it using total internal reflection. And it's coming in and out of these devices at the speed of light. So you can imagine 100 gigabits of data flowing in and out of a computer, which is so small. So this is one image. And here you can see how the entire light is coming here. So it's instead of electrical pulses, now you're sending optical pulses. And it does everything which electronics can do, but it is a little bit better. That's what we say. So I'm hoping very soon the laptops or the computers that everybody is using or the cell phones everybody is using start using the photonics technology. And soon we would have laptops and cell phones and computers which do not heat up, because I know that's a really, really big problem. So with this, I would like to finish my research talk, and I'm open to questions regarding GRE, your career, and if anybody is interested in optics or photonics, just let me know. You can also send me a request on LinkedIn, or if you have questions, feel free to ping me there. So thanks a lot for attending, and now you can just ask questions.
All right, ma'am. Thank you so much. You have made this session just not only informative, but so much fun as well. And you've surely ignited a spark of curiosity in our minds regarding nanotechnology. I'm sure the first thing many of us will do today after this webinar is to Google what is photonics. So yeah, thank you so much for it. And the dais is open. If anyone has to ask any questions, they surely can.
Mm-hmm.
Yeah, hello. Hello, my name is Gaurav, and I want to ask that your photonics application is quantum computing, right? So you mentioned the CPU of 2 into 3 millimeters, but I have interested quantum computers, and they are usually 1 to 2 meters high, the processing power and the units you would see. So how could I relate to the photonics, right? The size is big, and yeah, that was my question.
So that's a nice question. And the thing is, right now, quantum computers are working on light, but they're using they're using equipments like big tabletop setups. But when you shrink everything down into these nanotechnology, You can, so if I have this really huge, what example should I give you? So if you have a big, suppose you have a room full with a big supercomputer, you can probably shrink it down to this really small chip. And that is how you can use nanophotonics to scale things down drastically. So that is a lot of research is going on in quantum computers on chips. So if you look online, you will find something there.
Yeah, I'm very interested, and yeah, thank you.
That is super cool.
Hello, ma'am. I'm Yash.
Yes.
So my question to you is, in how many apply? Like after bachelor's?
I can't hear you. Can you repeat? I did not hear you.
In how many different, yes, sorry. In how many different fields can an instrumentation engineering student apply after bachelor's?
I think that is the beauty of instrumentation. The sky is your limit. You can apply to sort of any field because we know how to do coding, we know how to do ladder diagrams, we know how to do transceivers and transducers, we know electronics. So you can sort of do whichever field you want. I am not sure about management, but you can also do biomedical because we did biomedical instrumentation. So yeah, you analytic, it's I think if you can frame it well, you can apply it anywhere.
Thank you, ma'am.
No problem.
Hello, ma'am. It's Unnati. I want to ask that how can make sure that we would get a boost in our technical as well as financial growth?
So do you mean after bachelor's or later?
Yes. After bachelor.
So after bachelor's, if you really did well in your studies, and it's not just the GPA, but if you know your concepts, I think you are actually at a good place to get into the market and get a job. But if you want more growth, or if you want like to get in at a higher position, then you should look for higher education, because I think it's all the stats that matter. Right now, so many of us are doing engineering, so you need to stand out of everybody to get that jump or the boost. So make sure you stand out a little bit, and if you are able to do that, I think it should not be a problem.
Okay, thank you, ma'am.
No problem.
Ma'am, this is a question from one of our participants. How important are the SOPs and LORs for the higher education abroad?
Okay, so that's a nice question. And as I mentioned in my talk, SOPs and LORs are very important. I would like to give you like a ranking right now. So the most important part of your application is your GPA. Then they would read your SOP, and then they would read your LOR. And the LOR is all equally important because that is providing substance and proof that you are actually a good student because a professor says so. And if a professor likes you, then that means you're a good student. So they want a good student. So SOP is very important, LOR is very important, GPA is very important. GRE is just a cutoff you need to be viewed in the university. So some like NCSU, North Carolina State University, had in my time they just mentioned that they need, I think 160 in quants for them to even see your application. So if you don't have that much, just don't apply, because they're never going to see your application. So you need to make sure which universities are applying, check their admissions website, go through it properly, what they want. And there are chances, there's another thing that, when you're applying, I did not mention it, but you can email the universities and tell them to waive your application fees. So you would save around $80 to $90. Because I know people apply for 10 universities and it's like $100 each university. So it's like $1,000 just for application fees. But if you email the graduate coordinators there and you tell them that you cannot afford it, it's fine to say that, they would waive your application fees.
Hi, this is Chinmay here.
Mm-hmm.
Can you elaborate more on the difference between the master's courses and the PhD courses?
The courses?
Yeah, I mean, what's the major difference and how are they different in a broader perspective?
So a master's, at least in US, people generally finish their masters in 1 year, and for them, masters just means adding another milestone to your degree or to your profile. So now you're not just bachelor's, you have a master's. So you'll get you get a pay rise. So that's why they do it. In PhD, it's a long process, and if you really like to do research, you'll have the same course options. The master's students get the same course option as the PhD students. So that's not a problem. If you want to do some, like I took some management courses on entrepreneurship, how to start a company, and that's very okay to do in master's because I don't have to pay for it. And in PhD, it's more about doing research than just taking courses. It's like a full-time job where I could go to the lab every day. I'm working according to my hours. And then I come back. If I have a course, I'll take it, and otherwise just chill at home after that. Does that answer your
Hello,
question?
ma'am.
Yeah. Thank you.
Hello, ma'am. Good evening. My name is Nilesh Kulte. My question is, after I got a job in company, what should I do for my better growth?
So after you get a job in a company, after bachelor's?
Yes, ma'am.
Okay. So as I said before, I think anywhere, if it's school or PhD or master's or anywhere, if you want growth, you need to stand out. Because right now you are competing with hundreds of students with the same skills that you have, the same score that you have, the same work experience that you have, maybe working on the same project as everybody else. So what makes you different? You need to show them that. So that's why I'm saying you should always get involved in things. Involvement is very important. So if you are in a company and that company has, I'm pretty sure companies have these events and organizations. So show up to those or give some ideas to your boss. Meet your boss. You should get in good terms with people, make connections, give them ideas. Even if they're stupid, it does not matter. It just shows that you have interest in whatever you're doing, and that would help you grow.
Thank you, ma'am.
No problem.
Hello.
Yes.
I'm Gaurav here.
Mm-hmm.
I wanted to ask you about what are your exact future plans regarding, would you like to get into job field or business field?
So for me currently, I think my aim is to start a new company on my research project in next year. So I'll be starting a company and I'll be working on that. So it'll be pretty hectic then. And we'll see how the company pans out, if it works, if it does not work. If it does not work, I'll probably join the industry and start working again.
So what are the exact basic requirements before moving towards getting into business?
Mm-hmm.
What would be the basic requirement?
So I think you need passion. And all the entrepreneurs or everybody who starts a company needs to have the passion to do something which nobody else can. So everybody has ideas, we keep on telling, day-to-day conversation, "Arey, iski to company banni chahiye. Arey, ye to bahut acha idea hai." But how many people actually take that idea and start a company? So if you know this idea is good, you know this would be successful, I would say just just don't start a company. You have to do some customer discovery first, that is there really a market for that company, or the product that you're talking about. And if there is, then go ahead and start a company. It's definitely risky, but I think this is the time when you can take risks, rather than when you have a family and other responsibilities. It's very difficult to take more risk. So right now you can take risk and you can proceed. You can make differences.
Ma'am, one of our participants is asking a question.
Yes.
Which SEM should we write GRE and TOEFL if we want to get straight into a foreign university after getting our degree directly? And actually, here's a series of questions. So second one is, how exactly do we apply for a foreign university? And the third one is the score of GRE and TOEFL, which would be appropriate to get into a good university.
Okay. So as far as I remember the questions, the first one was which year to apply, or
which semester, yeah.
So I don't remember which semester it was. So let me see. You apply in your third year, because in US the applications close in December. So that would be sixth semester, fifth or sixth semester, I think so. So
you can go directly to the foreign university after your graduation.
Go directly, then you have to be in your fifth or sixth semester, because they have deadlines. Or in the eighth semester would be all deadlines. So you'll have your admits in your eighth semester, and you would apply in your sixth and seventh semester.
All right.
So the entire seventh semester would be applications, and sixth semester would be preparing your GRE and TOEFL.
And the score of GRE and TOEFL appropriate for getting into a good university?
And so as I said, the score for GRE is TOEFL, you just need the cutoff, which is I think 110 or 100 plus something. It's not that important. But for GRE, on an average, I think 310 is good enough as a cutoff to get into a good university. I had 310. I got into a good university because my university cares about GPA more than GRE. And a lot of universities in US are now shifting away from GRE. So a lot of universities don't even want you to submit GRE scores. They just want your GPA. So yeah, so it depends. And some universities are very, very into GREs. So they'll be like, no, we need 330 or we need 325. So just make sure, go to the admissions page and see what's the requirement, if that's your dream university.
So that is like a clear sign for our students to start taking their academics super seriously.
Yes, and that's what I was saying, that nobody told me, and I was like, yeah, sure, I would study. And then, fourth year, we have time. We have like 8 semesters. You can study anytime. And then GRE, like I started preparing, and I'm like, okay, so I just put my average till third year, and they're like, yes. I'm like, okay, I wish somebody told me that before.
That worked.
Yes.
All right. If anyone has any other questions. Yeah, ma'am, you were saying?
I was just saying that does not work for a lot of students. It worked out for me, but a lot of my friends were not serious till the third year. And then they were like, oh shit, we just have a 6-pointer or a 7-pointer. What are we supposed to do? So what they did is, this is something I wanted to tell. What they did is they averaged 8 semesters for an 8-pointer. And they calculated how much they need at least in the next semester so that they get an 8-pointer. So you can do that. If you have time right now, if you're in your second year, just figure out. If you have a 5-point something GPA, it's okay. Just see how much you need next semester, or these few semesters to get at least 8, and you should be good.
All right.
There's time.
Hello, ma'am. You mentioned about your startup. What is your startup idea?
So the startup idea is actually this thing. So I'm trying to. So the biggest reason, you don't see photonic devices or your cell phones having really thin surfaces or no heat release is because it's very difficult to send light from this really thin fiber to nanometer scale waveguide or another electrical wire, photonic wire. So my technology is about how we can make it more scalable and possible, so it's cheap and efficient and that everybody can use it. In one sentence, I can say that till today, if I was using a photonic device, I was only getting 20% output. So I'm sending in 100%, but I would only get 20% out. But with my technology and my device, we are now getting 80% output. So the efficiency has increased a lot, and now we are on par with electronics. So now we can think about shifting completely to photonics. That is the start.
Thank you, ma'am.
No problem.
Hi, ma'am. Gaurav here. I have a question that how internship could affect the selection process in universities.
So it definitely helps because you are adding work experience and now you are different than anybody else who has not done a job or who has not done an internship. So definitely, if possible, do an internship in your second year. Another thing, I thought I was going to do an internship in third year or fourth year, and then it doesn't make sense anymore because I've already applied, so it doesn't matter. Do an internship in your second year or third year and make sure it's related to what you are planning to do in the future. Because in India, you can just get an internship anywhere. I know how things work. But it does not add anything to your SOP or your resume, and they care about that. They need to see, suppose I am doing an internship in computer science, but my goal is optics. So they'll be like, how does it help? So it's my duty to explain it to them that I can use my computer science skills that I learned in the internship in optics. So for example, what I would say is I will be working on, I want to create something like a automation program for selection of optical equipments, which is completely automated, which runs on a script using the skills that I learned in my internship. So you need to tie things down and make it sound very fancy. So you can.
So if we can't explain it to them, then it can be a negative point.
Yes.
Okay. Yeah.
Or you can, just as I told you, I gave an example about how you can tie things down. You can add computer science related to optics. For me, if you want to go to electrical engineering, you can be, I want to make a programmable controller board. And you think you were lacking computer science skills. That's why you did that.
Okay. Yeah. Thank you.
Mm-hmm.
All right then. Thank you so much, ma'am, for addressing all our queries. And we wish you good luck for your startup and we hope you succeed in it.
Thank you. Thanks a lot.
So now I'll request our General Secretary, Gaurav Gunjal, to extend a vote of thanks to JUNIYALI NAURIYAL ma'am for giving us her precious time and advising us and guiding us for our careers.
Thank you, Janvi. Hello, good evening, everyone. I am Gaurav, General Secretary of ISA-RGIT Student Section, and on behalf of the Instrumentation Department of Rajiv Gandhi Institute of Technology and the volunteers, would like to extend a very hearty vote of thanks to our today's speaker, our Instrumentation Department's alumna, Ms. JUNIYALI NAURIYAL, who took out valuable time from her busy schedule. I must mention our deep sense of appreciation to Ms. Janvi Sail, who is the president of ISA-RGIT, for her work. I also wish to express my gratitude to our management and Honorable Principal, Dr. Sanjay Bokade sir, for providing encouragement and support. I'm very grateful to all our professors for giving us an opportunity to organize this event. Special thanks to our HOD, Dr. S.P. Sadala sir and Professor Anish Chame for helping us granting permission for this webinar speech series. Also, I would like to extend a special thanks to Professor Dipali Joshi Jain, who is our ISA-RGIT faculty advisor, for always inspiring us and guiding us. Juniyali ma'am, I especially like the way you have navigated our colleagues and have given a glance of different challenges and opportunities which they might face ahead through this webinar. The way you have explained the topic is exemplary. Your journey has convinced us that doing something that we would like to do first is our first priority, which would definitely lead us to our success and growth. The difference between the master's and the PhD, resume key points and content, and how extracurricular activities and our GPA matters, how much our skill sets matters. You have given a vivid idea about it. As no program can become successful with a single person, so I extend my big thanks to our ISA-RGIT team and the Instrumentation department for the support and all our volunteers too. Thank you guys for making this event successful with your contribution. Thank you, Juniyali ma'am, once again, and I'm sure this webinar would help most of us in our future career paths. Thank you. Now I would like to give it to Janvi.
Thank you, Gaurav. Now I request everyone to stand up in the honor of our national anthem. Gaurav. Thank you, everyone. I would like to announce everyone about our upcoming events now. We'll have a webinar on career opportunities in instrumentation by our alumni, Mr. Neil Shah, on 19th of July, that is tomorrow. And another webinar we have scheduled for you guys, which is titled as Industrial Internet of Things and 3D Printing by another of our esteemed alumni, Mrs. Saili Panchbhai, on 25th of this month itself. It will be conducted on Zoom and live on YouTube, and details will be provided soon, so stay tuned. And on that note, we would love to end this webinar. Thank you everyone for joining us. We are hopeful that this webinar will surely be helpful for you for making your right career choice. Thank you so much.
And I think I'll just thank all the teachers for telling me it was a good session. So thank you, ma'am and sir. Thanks a lot.
Well, it's a very good session.
Thank you, sir.
Very informative for your juniors.
Yes, sir. I was like, yes, I think this would be helpful.
Yeah, definitely it will be good.
It was very much informative and fruitful webinar, Juniyali.
Very good session, Juniyali. Very good.
Thank you,
excellent.
It's a really eye-opening session for your juniors.
Yes, yes.
It's not boring at all, and it's informative. Question answers session is very good also.
They might have motivated with this session.
Yes. Now they need a good GPA.
Yes, yes.
Involved in it.
Madam,
Yes, sir.
so can we go for that small video clip?
Yes, sir.
You already talked regarding those points to cover those 5 points. 5 points.
Ma'am, have we stopped streaming on YouTube?
Yes.
Stop, na?
Yeah, sir.
YouTube, yeah.